So we all know that a formula is something that is good to have because it helps us, do things efficiently. So here we have a formula called the quadratic formula, and it actually comes from the completing the square process. And we have a quadratic equation, and we use the process of completing the square. And if we simplify the process, we eventually would find the solution that is right here. And you can see it has A, B, and C in them. So the solutions have those in them. So what are A, B, and C? The A is the coefficient of x squared in the quadratic equation. B is the coefficient of x in the quadratic equation, and C is the constant term. So if we know the values of A, B, and C, we could simply plug it in the formula to get the solution. So this is a quadratic equation in the variable x. Now we could have other variables, so it doesn't have to be x, it could be y, it could be n, it could be u, what say you? So here we have 3n squared plus n minus 3. This is a quadratic equation in the variable n, but it doesn't matter what variable we have. All we have to do is identify the coefficients. So here the coefficient A would be the coefficient of n squared, the coefficient B would be the coefficient of n, and C is simply the constant term. The coefficient of n is simply 1. So A is 3, B is 1, and C is negative 3. So we are trying to find the solution for n. So n, according to the formula, is minus b plus or minus square root of b squared minus 4ac divided by 2a. We know the value of b, which is 1. So b squared is 1 squared minus 4 times a times c divided by 2 times a. So we have negative 1 plus or minus square root of 1 minus 4 times 3 times negative 3 is 36 divided by 6. So we have negative 1 plus or minus square root of 37 over 6. So mind you, the equation is in the variable x, therefore the solution, in the variable n, therefore the solutions are n equals minus 1 plus square root of 37 over 6 and minus 1 minus square root of 37 over 6. And here we have the next example, where 11n squared minus 9n equals 1. So note that the 1 is on the right hand side. We need to have a quadratic equation with the right hand side as 0. So we're going to achieve that by moving that 1 to the left hand side. So we have minus 1 equals 0. Now we can identify A as 11, B as negative 9, and C as negative 1. And this is a quadratic equation in the variable n. So we just have to plug it in the formula to find the root, the formula of roots. The formula is minus b plus or minus square root of b squared minus 4ac divided by 2a. So minus of minus 9, b is minus 9, plus or minus square root of minus 9 squared, minus 4 times a is 11, c is negative 1, divided by 2 times 11. Negative times negative 9 is positive 9, plus or minus square root of negative 9 squared is 81, minus 4 times 11 is 44, divided by 2 times 11, which is 22. So we have 9 plus or minus square root of 125 divided by 22. And we want to know if we can simplify this a bit further. We can with the square root of 125 term, because square root of 125 is simply 25 times 5. And 25 is a perfect square. So we have 9 plus or minus square root of 25 times square root of 5 divided by 22. And square root of 25 is simply 5. So we have 9 plus or minus 5 square root of 5 divided by 22. So the roots are 9 plus 5 root 5 over 22 and 9 minus 5 root 5 over 22. So here is a quadratic function with fractions in it. Now, if you are comfortable with fractions, it's great. But if you're not comfortable with fractions, it is best to get rid of the fraction before we proceed. Now, how can I do that? So here I'm going to multiply both sides by 8. So I would have 8 times 1 over 8 x squared plus x minus 5 over 2 equals 8 times 0. Distribute the 8. We have 8 over 8 x squared plus 8x minus 8 times 5 over 2 equals 0. The 8's would get cancelled. So x squared plus 8x minus the 2 and the 8 would get cancelled. So we'd have 4 minus 20 equals 0. Of course, you don't have to use this approach. We could simply go with the fractions, but as I said, some people are comfortable with fractions, whereas others are not. So it's entirely up to you. I personally would say rewriting it this way would be better, because it is going to get rid of all the fractions and we end up having a quadratic function in terms of the variable x and without fractions. So here we could see that a is 1, b is 8, and c is negative 20. So all we have to do is plug it in the formula. So x is equal to minus b plus or minus square root of b squared minus 4ac divided by 2a. So b is 8, so negative 8 plus or minus square root of b squared is 8 squared minus 4 times a is 1 and c is negative 20 divided by 2 times a, which is 1. So we have minus 8 plus or minus square root of 64, 20, negative 20 times negative 4 is positive 80, divided by 2. So minus 8 plus or minus square root of 144 divided by 2. So we would have minus 8 plus 12 over 2 and minus 8 minus 12 over 2. We end up getting 4 over 2 and negative 20 over 2, which is 2 and negative 10. You can always verify the solution by taking the values that you have, which is 2 and negative 10, plug it in the original equation in the left hand side, and the right hand side must become 0. But as long as you do the process properly, you can be confident in the solution that you get. So the key thing about this problem is whether to convert the fractions to numbers or keep them as fractions. You can keep the 1 over 8 and negative 5 over 2 as is for the values of a and c, and use the quadratic formula, but that is just going to be overly complicated unless, of course, you love fractions. So all the examples that we've seen so far resulted in real number solutions. For instance, we had 2 and negative 10 here, and we had 9 plus 5 root of 5 over 22, 9 minus 5 root of 5 over 22, negative 1 plus square root of 37 over 6, negative 1 minus square root of 31 over 6, and so forth. Does that imply that the solution to a quadratic equation would always be real? The answer is not true. Or no. So a quadratic equation could have real or imaginary numbers as solutions. So we could have real number as a solution, or we could have imaginary numbers. And the key thing to note is that this happens because of the b squared minus 4ac in the quadratic formula. So the quadratic formula states that x is minus b plus or minus square root of b squared minus 4ac divided by 2a. And that part inside the square root is what we call the discriminant. And that expression will determine if the root or if the solution that we obtain for the quadratic equation is going to be real or complex. So if that discriminant, which is b squared minus 4ac, is positive, we have two real solutions. In the sense we have real distinct solutions, in the sense we would have two numbers as solutions and they're not the same. They will not be the same. So we could have 2 and 3 as a solution, or 1 and negative 7 as a solution, both of them are real numbers, but they're not the same. If it is 0, then we would have exactly one real solution, in the sense the solution is real and it is repeating. So what do we mean by that? So case 1, an example here would be x is equal to 2 and 4. For case 2, it'd be 2, 2. So we have only one real solution, but they are, but it is repeating. The last case, excuse me, is when we have a negative discriminant. If we have a negative discriminant, in the sense b squared minus 4ac is a negative number, the solution is complex or imaginary. A key thing to note here that the two solutions, the two complex solutions, are conjugates of each other. As an example, if 2 plus 4i is a solution, then 2 minus 4i is the other solution, because 2 plus 4i is the conjugate of 2 minus 4i, and vice versa. So here is an example where we have to use the discriminant to determine the number and type of solutions for the following equation. Keep in mind, we don't have to solve for the equation. All we have to know is what type of solution we can expect to have if we have to solve this quadratic equation. So if I rewrote the expression in the standard form, we have 12x squared minus 4x plus 5 equals 0, which would mean a is 12, b is negative 4, c is 5. And we know the formula of the discriminant is b squared minus 4ac. So the value of b is negative 4 squared minus 4, a is 12, and c is 5. So negative 4 squared would be 16, and we have minus 4 times 12, which is 48. Multiply that by 5, we have 240. There is a negative, so we have 16 minus 240, that is negative 224. Negative 224 is a negative number. So the discriminant is negative. Which would imply complex solutions. So even before you start the problem, you could sort of plug in the values of B, A, and C in the discriminant formula to determine if one would expect real solutions, complex solutions, real distinct, or real repeating. So here's another equation where we have A as 2, B is negative 7, and C is negative 4. The discriminant is b squared minus 4ac. The value of b is negative 7, so negative 7 squared minus 4 times 2 times c, which is negative 4. So we have 49. Negative 4 times 2 is negative 8. Negative 8 times negative 4 is 32, which gives us 81. 81 is a positive number. This would imply the two solutions are real and distinct. So what does it mean if we have these different cases? So key thing to note is the solutions to a quadratic equation are the points where the curve, which is U-shaped, we call it a parabola, crosses the x-axis. So if we end up having a positive discriminant, it tells us we have two positive real solutions. Which would imply two intercepts, specifically x-intercepts, and that would be the two x-intercepts. Now, if we have the discriminant equal to 0, then that particular case would have one real solution, but it repeats twice, which would imply one x-intercept, which is right there. Now, if we have imaginary solutions, the conclusion is that the curve never crosses the x-axis, which implies no x-intercepts. So we can obtain lots of basic information just by looking at the discriminant, and oftentimes the discriminant could tell us what we can expect in the solution.